Hello everyone. So today I'm going to work on this NPC crocodile characters. So they just randomly roam and they just free roam, and when they see the player character they will start following the player character and they will attack me when they are closer, like this. If I run away they will continue to follow. Okay, so that's what I am going to do today. And this episode is sponsored by this generous patron. Thank you very much for the support you are giving me. Okay, so this is our crocodile character, the NPC character. So at the moment it doesn't do anything, it's just stay there. So I'm going to create a behavior tree driven AI blueprint for this crocodile. So eventually it is going to attack the player character as well. First let's start with giving some random random movement to the crocodile. Right, so first in order to navigate for AI characters we need a Navmesh bounce volume placed in the world. Otherwise the NPC characters can't find path. So I'll move this Navmesh bound volume to the 0 and set a scale to 100 by 100 by 100, so it encompass all this landmass, the landscape. And if you press P you will see in green, so this is the generated Navmesh, which shows the areas the NPC characters, AI characters can navigate. Right, now, so as for the animation blueprint, it's nothing serious. Actually this has the parts that we worked on before, which makes the character align its tail to the ground. We already covered that in this Unreal Advanced 𝐂𝐴 tutorial. Right, now let's go ahead and create an AI controller. Let's use tutor crowd controller. So as the parent class, actually it doesn't matter much at this moment. Well, AI crocodile. Right, now here we don't have anything, but I'm gonna assign that AI controller, AI crocodile, to use by the NPC crocodile. Then here in order to work with this, to drive this AI controller, I'm gonna create a behavior tree under artificial intelligence behavior tree. I'll call it BT crocodile, and also I'm going to create a blackboard BB crocodile. So the behavior tree defines the behavior, and the blackboard is used for communication, to save and load data into the blackboard, and it can be consumed by the behavior tree and the tasks. Right, now I'll open the crocodile, and as the blackboard I'm going to use BB crocodile for BT behavior tree crocodile. Right now in the AI crocodile, in the begin play, I'm going to run behavior tree, and as the BT asset, behavior tree asset, I'm going to use BT crocodile. Okay, now here from the root, we have the root at the beginning. From this we can have we can actually have only one node connected to the root. So here I'll add a sequence. So from sequence we can have multiple nodes connected. They will be executed from left to right. So here what I want to do is I need this character to randomly move. Free roam. I'll name it free roaming. So first character needs a target to freely roam. So how does it find a target? Let's create a new task. PT, let's use PT task blueprint base. So when you create a task, it will be named as PT task blueprint base new, which is not very convenient. So I'll name it T stands for task, T find location. Right, let's open it. So here, in order to execute a task, first we need this event receive execute. Oh no, that's not. Receive execute AI. Yeah, this is the one, not this one, sorry. And also in order to finish a task we need finish execute. Right, so in between we have to do the actual tasks. So here our target is to find a suitable location the crocodile can move to. So we already have a reference to the controlled pawn, so we can get location using the control pawn, and around this location we can find a random location in navigable radius. So I'll set this as like 2000. So within this given radius, around this given origin, this node will return some random location that this character can navigate to. So how do we communicate this the location we found through this node to the behavior tree, and how to make the character move? So for that we can, so as I said before, I said in the blackboard we can use blackboard to communicate between the tasks and the behavior tree. So let's add a new key here, a vector. I'll call it target location, and so, and here I'll add a new variable in the type blackboard key selector. Now compile. So I'll make this public so it will be visible in the behavior tree, so we can assign which key this blackboard key should be assigned to. So I'll name this BB key, get a reference and set value as vector. Right, now as the value I'm going to use this random location given by this node. Compile, save. Right, now in the behavior tree, here let's drag a line and we can add a task. The first task is to find location, the tasks I just created. So when you select this, you can see BB key, and it is already assigned target location because this blackboard only have one key. If it had multiple keys, we can just using this drop down we can select. Right, let's move this up so we can easily see it. Now this task assigns the location, and we need to mark this as success. Right, and then let's add another task. By default we have these tasks and we have move to. So as the target location we can give another backboard key. So this is already assigned the target location because that's the only key we have. So first when we execute this behavior tree, it will go from here to here, and here it will find a location and character will move to that location. Then it will continue to do so indefinitely. Right, shall we test? See, the character is now moving. And if I go to the behavior tree, you can see now it's currently executing the move to part. Cool. Okay, now it changed its direction. Right, so basically that part is working. Okay, now the next part is if the crocodile see the third person, the player character, I'll make the crocodile to follow this third person character instead of just randomly roaming around. Okay, so how do we do that? Go to the AI crocodile. Here let's add AI perception. Perception. Yeah, AI perception. It's together. And under sense config, let's set site config, and as the dominant I'll give AI sense site. Under this we have to enable all three, otherwise it doesn't notice the player. But let's try without that first. So here when you select the AI perception, we have on target perception updated node. Break down this structure and use a branch. If successfully sensed, let's just add a print node to print the name of the actor seen by the crocodile. Oh wait, before that site radius. Okay, vision half angle I'll give 60. Right, now the crocodile don't see me. Let's go in front of him. Still he's not seeing me. right now. But if I enable detect neutrals and friendlies, it should work. Let's try again. See, now you see third person character is printed. If I go in front again, third person character is shown. So right, so for some reason I guess the third person character belongs to a neutral category or the friendlies category, so that's why we have to enable it in order to see. Okay, now one more thing. If I place another crocodile over here, this crocodile should see that crocodile too. See, NPC crocodile too, it notices that also. So we need some way to distinguish the other fellow crocodiles and the player character. So the crocodile should only follow the player character or enemies of the crocodile. So let's set up a simple blueprint interface like this. Let's call it PPI AI. Now let's call it PPI AI support. Otherwise it sounds like an interface that should be implemented by AI characters. Here let's add a new function is enemy, and as the output I'll give a variable enemy, and let me open the third person character and implement that interface, which is PPI AI support. Now on the interface we have is enemy, so I'll set this to true. Okay, now here let's have another branch like this. Now we can access the actor seen by the crocodile, and we can check if that actor seen by the crocodile is an enemy or not using this isEnemy function. So let's have another branch like this. If it is an enemy only, let's print the name. Let me break this and do an append, print the name and add scene, so that's more clean. So now even if the other crocodile could seen by the other crocodile, name is not being printed because it's not registered as an enemy. But if the player go here, you can see third person character C, and it works for both crocodiles. See, all right, now what? All right, now let me disconnect this and let's have another selector node before the free roaming, and in the blackboard I'll add another key in the type of let's use object. Let's call it enemy. and the key type is object here. Oh, wait, why behavior tree is grayed out? Is it because I added this? Alright, it is okay now. Right, now I'll add another key connection from this selector. Now here under this free roaming we can add the decorator, a blackboard based condition. So here I'll use enemy. If enemy is not set, this part should execute. So otherwise, let's add another sequence. So basically what I need to happen is, if there are no enemies, the crocodile should keep roaming freely. If there is an enemy, the crocodile should find the location to the enemy and move towards the enemy. Right, so yeah, let's create another task. T move to enemy. Okay, now you see this event receive execute AI, just like before. Let's add receive execute and finish execute. So let's define a key to access the enemy object. Blackboard key selector, get value as actor. Right, now using the owner controller, pawn AI move to, let's use this node. And let's connect the controlled pawn here. On success, let's finish the task with success. On fail, let's finish execute with the success false. And as the target actor, I'll give the BB key, whatever in the BB key. Right, now let's add the task T move to enemy. So this should execute only if the enemy is set. Oh wait, I still forgot to set the enemy. In here, yeah, in here we can get blackboard. I think both works. I'm not sure what the difference. Set value, set value as object. Yeah, and as the object I'll give a reference to this actor seen by the AI. And key name, let's make a literal name, the key name is enemy. This should match the key name I have given here, otherwise it won't work. Right, now when the player go out of the vision area, now let's worry about that later. Now let's see, let's test. Oh, they ran into each other. Cute. That's a bug actually. Okay, I'll go in front of them, and now, oh wait, now that guy saw me. Let's see if he comes towards me. Oh wait, move to enemy. Is this working actually? Oh wait, we have to set this public, and we have to assign as the BB key enemy. Yeah, right, now let's test. Okay, let's go in front of this crocodile. Okay, now he saw me and he keeps following me like that, and the other guy haven't seen me. If I go, if that guy also saw me, yeah, now he's seen me or not. Okay, now both have seen me and they are following me. Let's check to be sure. Okay, now they are following. That's why this path is executed. Okay, and let's implement attacks as well. First, let's see, do we have attack animations, bite animations? Oh yeah. Okay, we have this bite animation. Let's create a montage from this. And here let's add a custom event to attack, but we need a way to access that event from AI controller tasks as well. So let's create another blueprint interface, BPI crocodile attack. Now in the NPC crocodile, I'll go to class settings and implement BPI crocodile, and here let's implement attack event, and here I'll just play any montage. Wait, do we really need this? Let's first go here and let's add another task to attack. T attack. Execute yeah, under control prompt. Let's play anim. Oh, we can't. Right, but we can call attack, and after the attack we can have a delay. Oh wait, we can do that in the behavior tree itself. Finish execute with the success. Right, now I'll implement attack play anim montage crocodile attack. First let me check if I have implemented slot animations. No. Okay, so I'll add the default slots so that I can play animation montages. And now in the behavior tree, let's call attack T attack. Right, and now here as the acceptance radius I'll give 100, because otherwise character will overlap with the player. Now let's test if they attack me. Let me go in front of him. Okay, now he saw me. Let's go closer. Okay, it does attack, but it comes too close. Let's make it 300. Okay, it is attacking, but it continue to play in the attack animation. So I guess this 250 should be enough. And here after T attack, let's wait like not 5 seconds, three seconds, and let's add one of the random deviation. Now maybe 0.5 random deviation, so there will be some difference in the waiting time. Okay, right, maybe 3 seconds is too much, but it is working, and it doesn't do actually any damage. But as for the moment, I don't wish to implement those things too. I only want to show you guys how to implement the behavior tree for the crocodile. Okay, so let's go to this guy as well. Okay, so with that I'd like to stop this episode.